Supersonic flight has its fair share of challenges, but with new innovations in the works, will we see more commercial supersonic planes? This is Supersonic, the hedge fund plane. So, MVP, what's the topic for today?
The topic for today is, will we ever fly supersonically over land?
Ooh.
And how do we want to do that? Well, NASA says we want to do it by turning sonic booms into sonic thumps.
Sonic thumps. I'm curious how that works.
Me too. I guess what kind of baffling measures you have to do, but with those baffling measures, do you lose some sort of performance where you wouldn't be able to travel supersonically, or do you have to, or do you drastically increase your or lessen your airtime because the aircraft's now been made heavier, so you lose range because of fuel on board, fuel consumption rates, all that kind of stuff. I'd be interested to know that.
Oh, definitely interested. I mean, when you brought up already with the structures, I mean, for most people that don't understand planes, when they travel at the speed of sound or faster, all that stress and heat that builds when that thing is flying, it's gonna do a number on the structure. So for an aircraft to withstand that, it needs to either have some special materials made out of it, which costs a lot, or it needs to have material that's heavier, which also costs a lot. And if you go heavier, you're burning more fuel to keep it in the air, for one. So your range is going to be shorter, like MVP said. Your fuel cost is going to go up, obviously. And just all kinds of craziness for that, man.
Well, there's all sorts of stuff, even like logistically, right? So looking here at this picture of the NASA X-59, which is what they're using to test low boom technology. And then and they're kind of flying it over communities and kind of doing studies with certain communities around the country, probably more deserty regions. I would like ours, I would expect.
Right.
But look at the nose. Like, look how long that aircraft is, long and narrow. And so the nose on that, just for the simple fact that it has to be designed that way to maintain that speed and shed heat or minimize resistance as much as possible. But all right, let's put this into a passenger supersonic jet. How far do those gates now have to be extended from the terminal to be able to reach? Because the nose is now a 2.25 mile long. You know what I'm saying? Like,
right? Or they're probably gonna just, as soon as they hit the runway, they're just gonna have like this emergency rollaway staircase just to have like people get on and off, because like you said, it won't fit in the gate. Or they're going to have to like tow it in backwards so the nose points out, which means more time.
Well, they kind of still do that at Burbank Airport a little bit, right? You know, it's still a pretty small airport. So they just pull up the jet and then they have this kind of a ramp system that goes up to the door, and you just that's how you go outside onto the flight line and then up the ramp and into the jet. Same thing when you deboard or deplane. You know, so that might be the way to go. No more going through the jetways.
That's true. I think I've been, not Burbank, but I know I did that on a certain airport. It might have been LAX. I can't quite remember. So with supersonic flight, like, it sounds great, right? Everybody who doesn't want to go from California to New York in less than 2.5 hours? Sounds fantastic. I totally would love a flight like that. So when a plane goes supersonic, like, picture like the air as water, for instance. When something moves through it, it creates waves, and the sound travels in those waves, and then it expands in all directions. When a plane goes supersonic, it's catching up to the waves it's making in front of it. Can you if everyone can kind of picture that? And so when it catches up to the waves, it compresses them into one, instead of like 5, 6, however many waves, it compresses it to one solid wave. And then when it hits the ground, that's the resulting boom you'll hear, or the sonic boom, what everyone seems to know. Example of these is like thunder booms, the crack of a whip, the gunshot, or the shot from a bullet. similar concept. Like it's traveling faster than the sound waves themselves, and then so like it compacts it all together, and then instead of just small tiny waves hitting the ground at whatever time, now it's just one solid one.
Right. And so to put a speed to this, right? It's around 770 miles per hour at sea level or 660 at cruising altitude. So that's just to put a speed to what Six is saying here. Those are the kind of miles per hour or knots you'll be. Well, it says miles per hour, right?
Yeah.
Yep, miles per hour. You'll have to be reaching to achieve what Six has been explaining here the last couple minutes.
Yeah. And then contrary to belief, what everyone thinks, when a plane hits or cracks the sound barrier, it doesn't sonic boom once. It sonic booms the entire time it's in supersonic flight. So it's not just boom, it's a boom, 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 just like exploding the entire time it's flying. And
Yep.
and I remember we were talking offline in the episode. You mentioned something about like how much or how wide a boom is depending on how high it is.
Yeah, so it's a sonic boom is about 40 miles wide for every 1,000 foot of altitude the aircraft is up.
Or
So imagine if you're at 40,000 feet ripping across the Great Plains. So you got X amount of miles wide at your. So imagine that you're getting sonic boom. So imagine if we got 50 supersonic jets back and forth across the country all day. I mean, that's just a continual. Boom, 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 boom. It's gonna sound like a war zone all day long, man.
right. You said it's 1 mile for every 1,000 feet.
No, 40 miles for every 1,000.
40 miles. Wow. So like imagine, right? The average commercial airline flies about 20, 30,000 feet. So that's about 120 miles. This sonic boom is being heard as it's passing by. That's a city. That's a city and a half right there for most places. You know what I mean? Actually, no, that's like almost 3 cities. Like you would, if you took off at Orange County, you would hear the boom all the way up in San Bernardino County and maybe then some. Holy shit.
Oh my God, yeah. So imagine them taking off out of LAX and then San Francisco all day long. I mean, just boom, 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 boom. Oh my God.
Right. Everyone in the Midwest would just move out because like that's the only, or that's like peak of where they would be hearing the booms or when they'd be traveling that fast. I mean, you probably won't see them do it out of the airport right out the gate, but I'd imagine at a certain distance from the airport, they will freaking just light off the ignition and freaking take off, you know?
Yeah, I kind of wonder how long it would take for them, right? So let's say you're taking off out of LAX and you're going to New York. You're taking off, you head out over the water. How far out over the water are they going before they turn? To then how long does it take for them to get up to supersonic speeds? Probably not very long, but right, is there going to be regulations over the city of Los Angeles? Like, okay, you can only cruise, you can only hit this amount of speed until you hit San Bernardino County line, and then from there you can go full clip until you get to, let's say, Philadelphia, and then you got to back off because now you're getting over highly densely populated areas again, and people are going to be complaining about booms and whatever else. So to it, right, you say, okay, well, I can decrease the flight time from LA to New York from 6 hours to 2.5, but is it in reality 4 hours because of these areas that you have to slow down so you don't create the sonic booms? Or does it take longer because you can maintain that speed, but you have to now fly around certain cities across the Midwest or across the country, right? So it's not constant sonic booms all day. And then to it, okay, well, if I have to fly around these areas now, it's not beelining it. So now I'm burning more fuel. Now does my nonstop flight get one stop in it? So now my 2.5 hour flight is now 4 to 4.5 hours or 5. And it's like, well, what am I really saving?
Yeah.
I'm saving an hour maybe, but I spent $1,000 on a ticket versus 200. I don't know. There's a lot that goes into it.
Oh yeah, most def. And we were kind of going to like, so what effects do sonic booms have on the ground? Right. Well, besides the sheer annoyance of hearing boom, 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 boom the entire time, right? these sonic waves. I mean, picture like a thunder crash, like or a thunder strike. They rattle shit. They kind of weaken structures if they happen repeatedly. They can blow out glass. They can crack plaster, stuff like that. So imagine like what would occur naturally like once every so often. Now you're hearing this man-made version of a thunderstorm just pass by day in day out after how many flights. So I'd imagine building structures would eventually weaken and crumble after so many repeated sonic booms just passing by them. Matter of fact, there was an experiment the Air Force and the FAA did. It was called Operation.
Hey, real quick. I'm gonna cut you off. I'm reading back over this article and I had my data wrong. Mm-hmm. What you said, 6 was right. It was a mile wide for every 1,000 feet. So my fault. If you're at 40,000 feet, you'd have 40 miles of sonic boom coverage. So I apologize to everybody. I had my data wrong, but I just wanted to correct it.
I mean, that's
anyways, back to the NASA study.
I mean, that's still a lot, 40 miles. So yeah, so going back to this study, so they did a study, or they called it Operation Bongo, where they took a bunch of airplanes and then they flew it over, I want to say it was St. Louis, just to see how many sonic booms it would take to, or how would sonic booms affect the population there. And the first one they did like about 150 booms, and everyone just like, yeah, whatever. I mean, I heard it crack, but it wasn't bad. And so they did another one. It was Operation Bongo 2, where instead of 150, they did 1,000 sonic booms.
Jeez,
my God. 1,000. And so
that's not even like a gradual ramp up, right? That's like, 150. Well, nobody cried wolf here, so let's go for 1,000. See what happens. Let's see if we can make people's ears bleed. Like let's just go for it.
Full send, right? So the result from that is they found out that the booms, like it interrupted people's what's their sleep cycle. Like they weren't able to fall asleep on the right time. There's an actual word for the sleep cycle. I can't remember what it was called. But it affected that. It affected conversations. It did some damage to building structures, like with the windows and plaster, like I mentioned. And then certain farmers and whatnot, they were claiming property damage because the constant booms, it would either drive their livestock insane, or some of them supposedly died from all the intense sonic boom happening back and forth.
When I think about, right, also, it could send the animal into cardiac arrest, but what about a pacemaker, right? Does it disrupt a pacemaker at all?
Ooh, that's a good one. I'm curious because, like again, with like the repeated boom, 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 it's got to upset the rhythm of a pacemaker too. Because, I mean, pacemakers couldn't be near microwaves and stuff. So imagine like just that sheer shockwave of that 40-mile boom radius. You know what I mean?
So you're telling me when I'm older and I have a pacemaker, I won't be able to make pizza rolls? Well, I don't want to live. I don't want to live on this planet then.
I would assume. I don't know like how intense the microwaves need to be. I just remember seeing a sign in multiple workplaces that says caution microwaves, and some little blurb in there says if you have a pacemaker, just exercise caution. Hey,
interesting.
Weird. But yeah, like 150 to 1,000. Let's just like full send this and go times 10.
Not enough people complained, and we didn't get enough negative results. So let's step this up. All right, what do you want to go like 200, 250, maybe even 500, 1,000,
1,000. Let's
go 1,000.
Let's go full ham on this one.
I want 1,000 sonic booms.
Right, and then so the result of those, right, from Operation Bongo 2 is yet another reason why they banned supersonic flight on land. Like they could only do it like at sea, like when there's nothing else in between them. And that's kind of like where we are now with why we're not allowed to do supersonic flight on land. There's other reasons like the Concorde crashing for one, and again with like the whole livestock and migration whatnot. But that was another reason. Like, okay, we're not gonna do this no more.
Yeah, that's really interesting. So I think also about the SR-71, right?
Right.
That thing flew at Mach 2, 3 somewhere in there.
I think
maybe even faster per some of the archives.
Yeah, I think its fastest ever was like close to Mach 4 almost. I'm not sure if it hit Mach 4, but I know it hit close to it.
So So that's interesting. For sake of reinventing the wheel, now I'm sure maybe a lot of the design and internals that went, with the baffling of the engines and whatever else, that might still be classified data. But for sake of reinventing the wheel, uh, what were they using, right?
Yeah.
Or is that thing traveling so fast and it just hit so many booms that everybody's like, "What the hell was that?" Just kind of looking around. You know what I mean?
Yeah. Right.
Oh, thunder! I wasn't expecting storms today. Yeah, I don't know. But like Lockheed, they're developing the SR-72,
Hmm.
I believe.
No. Yeah.
I saw they published an article on that, and I know, and kind of in confirmation, Pratt and Whitney had also published an article. They had submitted the patent for those motors that were in the SR-71.
Mm-hmm. Mm-hmm.
They had resubmitted the patent to begin test and development on those again. So I'm sure they're coming up with something, right? Because the claim is that with new materials and technology, Pratt claims that they can push that aircraft with those same engines, just kind of going through an overhaul and a revamp of modern tech and material, Mach 6.
Choo.
Yeah. So how are they then, right? How are they then combating this? If they're even concerned about it, right? It might not even be a concern to them. They might not care, because a Mach 6, who's really catching you, and who's going to notice it? You're going to hear boom, boom, boom. The hell? Huh?
What was that?
I don't know. Carry on. Yeah.
Right.
Did somebody fart?
Right. Or it can be one of those where like they only fly it at night during a thunderstorm, so like they can't tell the difference. Like,
yeah, I don't know. I'd be curious to know how they're going to combat it, but or what their design is. But yeah, for sake of reinventing the wheel, but we know that's all proprietary, and I guess unless Pratt would get like the sole contract for the next wave of supersonic aircraft, we might not see too much of it right away.
Right. Now imagine that, dude. Mach 6. Let's do a little math here, man. Like, so the speed of sound, right, is 760 some miles an hour. At Mach 6, you're going 6 times that. It's like 4,600 miles an hour. Holy shit.
You barely get the engines spooled up, and you got to shut them off just so you can out of LAX, so you can coast into New York City in 30 minutes.
Right? Like by the time you get to full speed, you got to start slowing down.
I mean, that's what the SR-71 has to do now.
That's true.
So imagine Mach 6. They probably only fire up one engine for that.
Right.
Where are we flying today? We're only going to New York. Yeah, we're only going to need 50% on one engine for that, so that's fine.
Right. I remember when the F-22 came about, where they said that was the first plane to air quote super cruise, right? Where it's going supersonic and it's not even using its full potential yet. It's like not even in afterburners. Imagine, man, how fast that is. Like, you're cracking the sound barrier and the engine's not even trying yet.
Yeah, it's going, well, this is a nice walk in the park.
Right? Like, that's just out of control, man. Like, imagine super cruise. And again, right, like faster than the speed of sound, like you're going at least 770 miles an hour or faster. That's just that's just wild. And then with your turn radius probably sucks ass though, like the SR-71. Like it probably took like a whole state for that thing to make a U-turn.
Well, that's funny you bring that up. So one of the places I used to work, one of our pilots there was a retired SR-71 guy.
Mm-hmm.
And he said they were just before afterburner, and he said they missed their turn by 3 seconds, and they ended up over, like they were heading south, right? Heading from like Washington down the West Coast, heading south.
Yeah.
And they missed their turn by 3 seconds because they were going to turn over like San Diego and then rip out across the southern half of the United States. But they ended up over Mexico City. Like they were going so fast that they missed the turn by 3 seconds, and that's how far south they had to go. And I guess by the time they hit there, they hit full after and flew right across the Gulf back up over Florida. And I guess they were already over in New York again, and the Mexican government was like, "Hey, do you guys have a plane you're flying over us?" And we're like, "I don't know what you're talking about.
What plane?
What plane? What are you talking about? Fix your radar systems,
You.
U
You
L L U.
imagine that, man. You miss a turn by 3 seconds and you have to divert like a solid country just to
Thousands of
get back
miles.
into your original lane. Like I missed a turn, I just have to
Yeah.
go down like 5 miles. These guys have to go like 5 holes, like 5 whole states. Oh Jesus.
Yeah, that's crazy.
So, what are we doing to fix it? Right? What's the latest in hip hop that's going on with supersonic flight? There's this company, I think it's in Denver. They're called Boom Supersonic, and they're designing a plane right now. It's called the Overture. I want to say the name is, where it's air quotes supposed to be producing a quieter boom, as they say, right? Like the thumps we were mentioning at the very beginning of the episode. And
yeah, I think it's still just an overseas jet though, right? It's not one that they're flying overland, or is that they flying that one overland?
no, I think that one they're still experimenting overseas, and a lot of it I think is computer simulations as well. Because let's be real, like when they first designed the first batch of supersonic commercial planes, technology was like well before the Game Boy series. So I mean, they could only do so much. But nowadays, like we got computers that can pretty much fly themselves, so we're able to at least simulate most of these before we actually try it out in person. How efficient that is one thing, but to actually build a model and give it the gas that it needs to do these tests, it'd probably be a little bit more cost effective. Boom Supersonic also claims that this new sonic thumper of an aircraft has more efficient green biofuel, as they say. So like the fuel consumption would be a lot less. It'd be less impact to the environment. It'd be more bang for your buck, that I guess they would call it. There's a lot of skepticism about that. I'm not 100% versed about biofuel for one, and then for a supersonic jet to use biofuel. But
how much of it's really bio though, right? Like,
true.
what makes it biofuel?
Yeah,
That's what I would want to know. What's the concoction there?
right. Just like they say, like, oh, these oils that we use, they're synthetic. They're made from like plant based shit. Like, I mean, it still burns like hell, though. I'm just saying.
Yeah.
You know, it still sucks to get it on your skin, but okay, whatever you say, coach. And again, going back to what we were saying earlier about fuel consumption for supersonic jets. I mean, fuck, like the Concorde burned like actually almost all supersonic commercial jets burn 5 to 7 times more than a commercial airliner. So what you would normally pay, like, I don't know, like, or use up like 5,000 pounds worth of fuel. Now you're using 10 to 15,000 pounds worth of fuel just for the same amount, same distance.
Well, right. So can we make it that far? You know, let's take the Concorde, for example. Can we make it that far, or can we? What kind of design limitations? Like, how many people could fly on the Concorde? I don't even remember, but
I don't remember.
I know it's not going to be like a 747 type numbers. You know, at least not yet.
No, nowhere near. Because even if you could get it up to numbers, that plane is going to be so freaking huge just to make it aerodynamic enough to be supersonic or sustained.
Yeah. So back in the early to mid 2000s, right? I'm reading here that NASA worked with Gulfstream and McDonnell Douglas. They fit in an F-15 with a quiet spike, which protruded 24 feet from the nose.
Oh my God.
And that's on the size of an F-15 that they did that. So imagine now the size of a Concorde. Well, I mean, we've all seen a Concorde, but imagine whatever new designs are coming up with.
Right.
If you have to do a 24-foot spike, now does that 24-foot spike model type, whatever, not, you know, that's just what the math and the sciences worked out to be, that 24 feet off the nose of any aircraft is good enough to reduce those sonic boom noises? Or is it for every, you know, okay, this aircraft's, you know, 35 foot long, so it needs 24-foot spike, but a 747 being the size it is needs an 87-foot spike off the nose? Like, what?
Right.
I don't know. right? It doesn't explain that, but I'd be curious to know. If there's anybody listening who's like a aerospace engineer or really good at this, knowledgeable on this stuff, hit us up because I'd be curious to know.
Yeah, please. Like all these flight science critical stuff. We're really curious to know because it would be nice to have a commercial supersonic flight, but you know, what I mean, as of right now, the practicality of it is very slim. Especially when you come down to that cost, you know, for both fuel, for maintenance, and then for the commercial passenger, right? Because you know this stuff is only going to be available to like someone who's like got that kind of money to drop for a supersonic flight or a
Well, it's probably going to be. So I know Virgin is developing a fleet of supersonic passenger jets. I don't really know how far along they are with that, or how many they have, or if it's still in the design phase. You know, but you know, let's just say, I mean, hell, plane tickets right now can run you from, well, let's just, you know, if you're flying Spirit, you know, let's go $60 all the way to uh 1,000 first class on like United or something like that, right? So
Mhm.
if you're telling me we can only fit, let's say we can only fit 30 people inside of this supersonic jet, are them tickets going to be like 2 to 3,000 a piece? You know,
Oh,
in
easy.
which case for a family of five, like you're telling me I'm going to be paying $15,000 just to fly back east and visit family? Like, I
Yeah,
don't know
right.
about that.
Right. I'm like how important is your trip to get there that fast?
Yeah. Yeah. Oh, grandma's passing. Yeah. Yeah, she is, but I can't justify going into blinding debt to get, I mean, it sounds real insensitive, but you get what I'm saying. Like,
Yeah. Going into plane. And then you know like the accommodations in the plane itself, it's not gonna be luxury level. Let's just say that. It's gonna have the bare minimum because it needs the maximum amount of power to weight just to get it off the ground for one, and then to minimize the actual cost of both the fuel and the maintenance to get it going. So you'll get there real quick, but it'll probably not be a comfortable flight the whole way through. Just saying.
yeah, well, the good news, I guess, if you're not going to be that comfortable, at least it'll be shorter.
Right.
That's
No.
probably how they'll sell it too. Yeah, you won't get peanuts and a Coke while you're flying. Just sit down and shut up. You're going to get there quick. You know, like, I don't know.
Right. Or there'll probably be some Top Gun cliche shit, right? Like do you feel the need for speed? We do too. And you get there in 3 hours or less. It's gonna, you know what I mean? It's gonna sound like some pizza delivery shit, like 3 hours or less, or the flight's free.
Treat it like Domino's delivery. You get to New York from LA in 2 hours and 30 minutes, or the first 45 miles are free type thing. I don't know.
Some shit, right? So, going a little bit about the aircraft structure itself, we mentioned, you know, it's got to have some like new shit material, or it's got to be heavier. The Concorde itself, like when it does its flight, it actually stretches like a good 6 to 10 inches from end to end. Imagine that shit, man. Like, and then when it lands, like the air crew, they're just looking at it, or the maintenance crew just looking at it, like, God damn it. Well, here we go again. Yeah, I'd imagine like the NDI inspections or the structure inspections would just be through the fucking roof. You know what I
Well,
mean?
right, yeah. If you have so many phase inspections for every amount of flight hours now, I imagine it'll be double or triple of that for a supersonic, just because, like you said, the aircraft itself is stretching 6 inches each time it does this.
Mm-hmm.
What materials are they using? But how often can you stretch it before it becomes work hardened and weakened and becomes a critical point of failure?
Right? Yeah. Or like some early supersonic jets, like the early models of the SR-71, like they would have gaps in between the skin on purpose. So, and the reason for the gaps is when it went supersonic, the skin would heat up and then it'll expand and close those gaps. But the whole time prior to getting to the supersonic level, all those gaps would cause fuel leaks and it'll just be pissing fuel everywhere right up until the point where they hit supersonic. So can you imagine like commercial
Well,
planes like that?
the fuel system would just have a bunch of crazy ass expansion joints. But also, what about tire, right? Rubber material and the gear, and what kind of stress is that putting on there?
Mm-hmm.
I don't know.
Oh yeah, and you know these things, like, since they're meant for speed, they're not going to be good when they're slow. You know what I mean? Like,
Yeah, they probably will barely fucking stay afloat.
I'm thinking this like in the sense of cams, right? Like, bigger cams means more power, means faster speed, but they fucking suck when they're just driving down the road like at the speed limit. So
Yeah.
you're just like burning fuel and you're rattling all over the place. I'm like, this ain't a fun ride. So you have to at least get to 60 miles an hour just to even feel comfortable in the car. You know?
Yep. Yeah, it's one of those when they say it idles at 80 type thing. That's kind of what these jets will be.
Right. So like these ones, like, they need to get up and away like super fast just so they don't waste fuel and induce more ground related stress before it even gets into the air.
Pilots will be complaining this thing handles like garbage until you hit 600 miles per hour or something like that, or 500 miles per hour at least.
Right. Yeah. And so with all the new innovations that are going on, like with Boom, Supersonic, and NASA and Lockheed and all them, so they're proposing to do another experiment like Operation Bongo, but Operation Bongo 3, and who knows how many booms they're going to try with these new sonic thumpers, as they call them. So, Operation 2 was 1,000. So, like, let's try 5,000. Fuck it.
Oh, man.
Yeah.
I hope they don't do that over my neighborhood.
Can you imagine? Like, so, like, they say, oh, this will be quieter, right? But quiet is still really loud in retrospect. So, instead of boom, 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 you're just like, you just hear like...
Well, I hear sonic booms at least 3 or 4 times a day where I work, and they rattle the whole hangar. Right, every time it happens, just boom, 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 and the whole building's shaking, dust is falling from the ceiling. But I don't know, man. I mean, imagine that just being constant for 12 hours a day.
Oh,
like I don't know.
Right, yeah. And so here's another one for like the aerodynamics and flight science people. Like, so we know what happens when one plane goes supersonic and then cracks by a neighborhood and whatnot. What happens when there's 2 of them and they're going opposite directions? You know what I mean?
Like, well, that's a good point. What if 6 and myself are flying supersonic jets? And stop laughing. I can hear you all laughing. But let's just say 6 and I are flying supersonic jets. And we're passing each other, and we're both at he's at 35,000 feet and I'm at 30,000 feet, and we're within 3 miles of one another, and we pass each other going supersonic. What kind of stress and issues are we going to run into, or even flight handling characteristics? Like what are we going to run into by him and I passing each other that close? I'd be curious to know.
Yeah. Or another one I would say is, imagine like a supersonic jet flying, right? Just doing its thing. And then there's at say 60,000 feet, for instance, let's just say that, or let's say 45,000. It's doing its supersonic flight, and there's a commercial airliner, like a 747, for instance, at 30,000 feet just below it, traveling behind it, right? Like, well, what's it? We already see planes when they get caught in each other's jet wash or prop wash, and it causes all kinds of crazy turbulence. So what's the turbulence going to be like when you're caught in the jet wash of a supersonic plane cracking past the sound barrier? You know what I mean?
Yeah. Or how about we got a supersonic jet taking off out of LAX? How long does the next jet landing behind it have to wait until that turbulence is minimized enough for it to come in safely and land?
Right. Yeah. Oh, do you can imagine being the ATC for that kind of shit?
Yeah, I was gonna say, what kind of airspace clearance do you have to do for that? Imagine talking to about 15 supersonic jets coming in all the time. All right, November 791, you're cleared. Shit, he's already gone. Fuck, they're already landed. You just be trying to, you'd be behind the curve all day. I feel like.
I mean, I'd imagine an ATC's job is like super stressful as it is with regular planes going in and out. Probably like top speed, I don't know, is like what, 600, like 500 something, 600 something miles an hour. Now you're dealing with ones that crack the sound barrier on a whim.
Right. Just because they can.
Yeah. So you got to give them like a whole city and a half's worth of cushion. Like they got to radio in their landing time well in advance because, like, say, like with the SR-71, they missed their turn for 3 seconds and now they're in Mexico.
Yeah, it's like imagine that though. Like imagine the plane where there's a thunderhead, right?
Mm-hmm.
Uh, like do they fly over, around, under, or do they just they're going so fast they just make it through without? But then, like let's say you got lightning crash around you. I don't know if you've ever flown in an aircraft when there's a sort of a thunderstorm going on in and around
Mm-hmm.
your area of flying. And lightning bolts, as we said, create that same sort of a pressure build up, which is what creates the thundersonic booms, right?
Yep.
So how does that work too? If I'm flying supersonic and also lightning crashes around me
Mm-hmm.
and thunder's rolling, do I run into adverse effects more so than a normal plane would? I don't
Ooh,
know.
that's a good one. Yeah, weather would definitely play a big factor with supersonic. And then what is going to be like? You can only fly supersonic on a clear ass day, no wind, no nothing. You're like, well, fuck. There goes like 90% of our revenue.
Yeah, no kidding.
Oh, I could just imagine like so like I'd imagine like going supersonic. You have to be in a straight line and everything has to be semi perfect. I imagine if you fly through stuff that has like wind shear or abrupt wind changes and shit like that, that just like what would be like regular turbulence to a commercial airliner. I wonder what that would do to like a plane going supersonic. Like just how much would it blow it off course? You know?
Yeah, I'd be. It's a good question. We really need some flight science people to chime in from this episode. So we had talked about the sounds, right, going from a boom to a thud.
Mm-hmm.
Um, so acousticians um, at NASA are using a perceived decibel level, or PLDB. So the Concorde's boom was around 103 PLDBs, perceived decibels levels. Roughly the loudness of nearby thunder or a car door slamming while you're inside the car. 75 decibels, which is NASA's goal for their new supersonic transport jet they're testing, which is what I mentioned earlier in the episode. They say it's currently about an eighth as loud as what the Concorde was. That's the equivalent of distant thunder or a car door slamming 20 feet away. Like decibels or earthquakes, perceived decibel levels are measured on a logarithmic scale. Just for those of you who like to nerd out with that kind of stuff.
Huh. I mean, and that's a significant drop if you ask me. I mean, um, if it's that level of perceived loudness, I would say, I think more people would be down for it, to be honest. And now, are we willing to incur that kind of cost? That's a different story. But I mean, a gunshot versus, I mean, a rock concert versus a car door slamming 20 feet away from you. I mean, that's a significant difference.
Yeah, that's it's a massive difference.
Yeah. But then, go ahead.
Go ahead. Sorry.
No, I was just saying, but then again, we go back to our previous questions like what happens in the jet wash? What happens when two booms go opposite of each other in weather, the high maintenance cost, the high fuel cost, all that and other. That's a lot of variables that we have to test out or at least have substitute solutions for. And
Yeah, I would like to see the maintenance list, right? So as this article goes on, it actually talks about Lockheed's. Um, they're currently building a plane, which is kind of that one I was talking about earlier, which will fly over American cities in 2024, which isn't too far off. It says it's another X-59, but it resembles a mini Concorde, I guess, is what they're saying.
Uh-huh.
It's 100 feet long with a wingspan of 30 feet, an engine centered on the tail, and more surfaces than appear necessary. Huh. Horizontal stabilizers are at both the bottom and top of the tail, and also on the nose. It says all those are used to tune those shocks from the program director there at Lockheed. That's interesting.
Yeah, it is real interesting.
So it says they hope to stretch the front of the boom wave from a single millisecond out to 20 or 30. So it's pretty interesting.
Yeah, I mean, That's times
So if
two.
you're wondering how we can all how I'm reading all that stuff, right? So this is all an unclassified program at Lockheed as well. Just so you're all tracking, like, oh, he's giving away secrets. No, I'm not.
This is all stuff found. This is all stuff like open, like press released and openly disclosed and all that stuff. So we're not divulging anything like intel dropping. You know what I mean?
Yeah, so I guess the reality of it comes out to is as testing and stuff goes on, we'll see some pretty unique designs
Mm-hmm.
to control these sonic booms a little bit. But I just curious to, as like we've mentioned a few times, what you lose in performance by making it quieter, so to speak, right?
Yeah. Or like you said, like how long does the structure need to be? Is it relative to the aircraft itself, or is it just like a set number? Like it must be X long to
Yeah,
um
24 feet is the perfect number to reduce nose pressure on the aircraft, no matter what aircraft. I don't know.
yeah. And then can you imagine, man, like the avionics and the computer structures that are going into these aircraft, man, because they got to be like so top of the line. And then
Oh, well, we say so top of the line, but you and I have worked on some pretty modern shit, and we're looking at like this is Vietnam era guts. Like, awesome. Good. I'm glad we had that in the back stock that we decided we're going to use now. Awesome. This is great.
Right.
By the way, are they making replacement parts for these? No, they're not. Awesome. So when this fails, we'll figure it out when that happens. Great. Thank you. All right.
No, we'll turn into like the
We'll
the B1,
cross that bridge
right?
when we get to it. Yeah, exactly.
We'll turn into the B1 where like I bet you that plane can be code red the second it leaves the deck. Like, fuck.
I know. We saw a B1. I saw a B1 take off one day, and one of the guys I worked with, he was an old B1 bomber guy, and I bet that thing wasn't even 1,000 foot off the deck. And he takes a long drag on a cigarette, looks at me, and goes, "I bet that thing's already code 3." And sure enough, it lapped around the airfield and landed. Code 3.
That's gonna be a majority of the supersonic planes when they get there while they're still trying to iron out the kinks. It's like, yay, we went wheels up and it's back.
Well, that brings up a good point too, right? Like, with all these stresses and added stresses and everything going on to it, operators and stuff are going to be trying to stretch those and employ those 10% rules all over the place. But yeah, how often you get to the airport 2 hours ahead of time, you get on your plane and you take off and you've been in the air 30 minutes. Oh, we're gonna have to RTB because whatever issue. So again, your whole flight's late. So you start questioning. I paid a lot of money for what? Should I have just gotten onto a normal airliner that's been proven for 50 years?
Right.
I'm not sure. Not sure what the answer is.
Now imagine like the training it would take for an aircraft mechanic to work on these fucking things. These guys got to be like NDI techs at minimum, right? And they got to be like almost like flight scientists themselves because of the amount of stress and tolerances these things have to take. You know what I mean?
Uh-huh. Yeah.
So, I mean, it's really challenging. There's a lot of challenges with this, and I'm really curious to see where it's all going to lead and what our solution is going to be. And hopefully, it's just not one of these hodgepodge, like band-aid over the issue kind of shit where they just throw a plywood over the pothole and just call it good.
Oh, so here, I kept reading through the article, and we're talking about how many people and stuff these aircraft are going to carry and whatever else, but probably not as much as a normal airliner, right?
Right.
So it goes through it's going to use like certain high definition cameras to allow the pilots and stuff to see the ground without like you doing what the Concorde did with that nose actually curved over to allow them to see down. So they're going to, which that added a lot of weight and expense to it, right? So they want to keep it just flat, but use new cameras and stuff like that we have out there so they can they'll be looking at the ground through cameras essentially. But they said Lockheed's going to make they said they wouldn't make a commercial version of the X-59, but it could partner with other firms maybe to create a passenger version. But they predict that it would be, if they did that, it would be 230 feet long, about the length of a Boeing 777, and carry only 50 people.
Holy
So
shit.
think about it, the same size as a 777 and only carry 50 people.
Jesus.
Wow.
Wow. So inefficient. And I bet you it costs just as much too.
Oh, I bet you it's more, man. Those 50 people are going to be paying out the nose.
Literally. Can you imagine that, man? Like, so 230 feet long, and it has cameras on the ends of the nose so they can see down. I'd imagine that'd be super disorienting, right? Because you're here in the cockpit, and then the camera is 40 feet away from you and below you. So, like, oh, Jesus Christ. And it
well, what about the pilots that are flying at nighttime now and all that stuff, right? And what do they call it, IFR or VFR?
Yeah.
No, IFR. IFR, yeah, flying an IFR. I mean, they got to use the instruments and gauges to land, so it'd just be sort of a similar thing, I guess. Just you'd be IFR even in VFR conditions.
True. That's gotta be weird.
It has to be, man. I think it would take a lot of time to, like, you would have to, like, okay, I see the ground here, which means I have to do the quick math in my head because I'm sitting 15 feet off the ground. The gear's this far below me, and
Yeah.
So when I see this, but I'm sure they'll have sensors that say that'll be even more accurate. That'll give you like laser altimeters and stuff that'll allow you to get an accurate reading of how far off the ground you are.
That's true. Can you imagine, man, recruiting pilots for that thing? You're like, hey, everybody, okay, we're having open recruitment now for a supersonic commercial airliner. Who wants in? And I guarantee, I can almost venture to guess that almost 80% of them will probably be like astronauts and shit. You know what I mean?
Oh yeah, I would think, or they'd be people who've been test pilots over the course of the last decade or more,
right,
testing all this stuff out.
True, very true. Can you imagine that, man? I'd imagine, like, I guess clout chasing for all those people who fly supersonic. Like, look at you, commercial people. What's it like flying below the speed of sound?
Well, I would imagine it's probably for some people it's like thrill seeking, right? Like, oh, I've been flying 747s for 15 years, and yeah, it's a good gig, but I want that new. I want to try something exciting, right?
True.
And I get it. I can see where it's one of those, like, hey, I want to have as many certs under my belt as possible. But how about flight hours, right? Do these get logged differently? I've got 1,500 flight hours, but no, I've got 2,000 flight hours. 1,500 are normal, and 500 are supersonic. I don't know. I don't know if that would be tracked differently or not.
Ooh, that is a good one. I'm curious. I mean, yeah, I would definitely like to know about that. Wow, we covered quite a lot, man. And especially with the amount of new stuff that's coming on with supersonic stuff. I like we were saying throughout the episode, I'm curious to see what their challenges are going to be and how they plan to solve it. And then overall, how they plan to beat cost. I think that's one of the bigger challenges that they're going to run against is what's the cost or the price tag going to be, and then what's it going to mean to us, the consumer, when we're actually using this thing.
Yeah, exactly. Well, it's all going to come down to money, right? Cost to build the damn thing, to maintain it, and then how do I recoup some of that back in ticket sales? Which, let's face it, I mean, even airlines now, the cost of everything, they're not really recouping much back in ticket sales, I wouldn't imagine. That's why a lot of them are getting government subsidiaries, but I'd be curious to know.
Yeah, very curious. If any of you listeners out there, you guys are flight scientists or aerodynamics or
hell, even working on one of these things.
Yeah.
And you can talk about it.
Yeah, please let us know. Tell us, like, what are some of the stuff that we are hitting and just kind of fall short on. Some of the stuff that common people don't know, and just some of the ins and outs of how these things work.
And with that, thanks for listening, everybody.
Thanks, everyone. Bye.
Bye.
We'd like to take this time to thank our patrons for supporting our show and allowing us to continue to make episodes, maintain our gear, and create merch for all of our listeners, with special thanks to Erica Lamont, Chris Hawkins, Ryan Freshour, Dan Schubert, Jenny Dignan, and the ladies of the Dick Talk and Mimosas podcast. Thank you all so much for your support and patronage. Visit our shop at cancelformaintenance.com and grab some swag to show off both your support for us and your prowess as an aircraft technician. If you have ideas for the show or you'd like to be a guest on the show, visit our contact us section and send us a line. We will do what we can to get your ideas or yourself on the show. You can also follow us on social media, such as on Facebook at Cancel for Maintenance, Instagram at Canx, that's CANX for Maintenance Podcast, or on Twitter at CXMX Podcast. Check out some of our affiliates like Rockwell Time, where they make both rugged and classy watches to fit your lifestyle. Use the code CX4MX and save 10% off your purchase. Support us on Patreon. Our patrons get exclusive perks such as access to our Discord, discounts and early access to merch, special patron-only episodes, and so much more. Thank you again so much for listening, and we'll see you next time.